Good morning, everyone. Welcome to the fourth day. Okay, so let's recap on whatever we covered yesterday and carry on. So project time management is all about preparing a schedule and maintaining it, controlling the timeline of the project to deliver the project on time. There are 7 processes. First is to prepare a schedule management plan which will guide us for rest of the activities. That is define activities, sequence activities, estimate activity duration, resources, estimate activity duration, develop schedule, control schedule. 6 processes are in planning and 1 is in control. This is the overall process. First we develop schedule management plan. Then we'll go for defining the activities of every work package we have in our work breakdown structure. After identifying activities, we sequence them, providing their dependencies. Either it is FS, SS, FF or SF. Then estimate the resources required for each activities. Then estimate the duration. Putting all together, we have a schedule which we optimize and make it acceptable by all the stakeholders. Freeze it. It will become baseline and then carry on for execution. On a regular basis, control the schedule. We can define the frequency in schedule management plan. The schedule management plan is basically a plan which contains what model we are adopting, what is the level of accuracy, what is the unit of measure, what is the frequency of reviewing the project, what are our control threshold, what is the rule we have or ground rules to measure the performance, in what format or in what information and in what format it will be communicated to stakeholder, the status of the project progress with respect to time. Then the first activity after that is identifying activities for each work package we have in our work breakdown structure. So scope baseline basically provide work breakdown structure. Here we take every work package which is the leaf in the whole tree, and we identify the activities that need to be performed to develop that particular work package. We also talk about rolling wave planning, right? Rolling planning means planning in detail in near term and planning at a broader level in the far term. What we get all the activities required to be performed on the project. We get activity attributes that defines each activity. That is who will do, when it will be done, what is the predecessor, successor, any WBS ID, etc. And we also make list of milestones. So we at a certain point we put some milestones, so we get the list of milestones as well. Okay, there are some of the things which can be considered as activity attributes. This is not exhaustive list. There could be more parameters also. Then it comes to sequencing the activities. Sequencing the activities means connecting these activities with the relationship they have from each other. Normally we use PDM, precedence diagramming method, also called activity on node. And what we get out of this is the project network diagram. Okay, so what we normally prepare is like this. This is a sample diagram. This will help us to understand which activity depends on what. Who is the predecessor of what? Who is the successor of what? For example, D is a predecessor of E and B, and F is the successor of E and B. Right? We normally have 4 types of dependencies. The FS, which is mostly we use FS. I said almost 80% of the dependency we assign in this network diagram, most of them are FS. In some cases we put SS, where the start of predecessor direct the start of the successor. The third is the finish to finish, that is the ending of or finishing of the predecessor direct the finishing of successor. So successor cannot finish unless predecessor is finished. And start to finish means some activity has to start to finish the other activity. We can apply leads and lag in this. Lead means we are taking a something like this. We are taking a lead over the dependency. So we start the successor even before the dependency is over. And in the lag is the opposite, that is some idle wait time. So our dependency is over, but we are not in the position to start the successor because of some external reasons. And whatever the time we will wait to start the successor is the time we call it lag. There are mandatory dependencies, there are discretionary dependencies. Mandatory dependencies are the dependencies which we cannot change, which are not in our hand. Right? So until unless you bring the food, you cannot eat it. So that is the hard dependency. Now discretionary dependency is that in your platter there are many things. You can eat anything at any point of time, that is your discretion. You can eat all together, or you can eat one by one, or you can have a sequence, or you use the random process, but it is your discretion. So such kind of dependencies are discretionary dependency, on which you can decide either I go this way or that way. Should I do in sequence or should I do it in parallel? So wherever I have the discretionary power, or where the situation is that I can make the changes, then they are discretionary dependencies. When we compress the schedule, when we crash the schedule, when we fast track the schedule, discretionary dependencies are the dependencies on which we do a reconsideration. Should we continue with the same way or should we make some changes? Often discretionary dependencies which are in sequence, we often make them in parallel, making some compromises to reduce the overall duration of the project if those activities fall on critical path. There could be some external dependencies, there could be some internal dependencies. When we apply these leads and lags and start to start, finish to start, the same network diagrams looks like this. Right? So here we have applied between E and B SS +1, so there is a lag of 1 day, and the relationship is start to start. Here the relationship is finish to start, but there is a lead of 2 days. Here between B and C, the relationship is finish to start with a lag of 5 days. That means C will start 5 days after B finishes. Now the next step is estimating the activity resources. So identifying the resources required for each activities and the quantity, in which quantity we need it. So what kind of skills are required in how much quantity, and how much quantity is available. So you look at this, we have some tools like alternative analysis. Alternative analysis is required because there is a fair possibility the resource we are looking for may not be available. A less experienced resource or high experienced resource, or that skill is not available, then we have to find alternatives what else can be done. A particular skills we are looking for, but that skill is not available right now. So we can think of providing a training on this and hiring a person and providing a training. If a 5-year experienced person is not there, we can hire a 3-year experienced person and provide some guidance to this person, provide some training and guidance so that this person can backfill the 5 years experience guy. We also used published estimating data. So what is published estimating data? There are various consulting companies like McKinsey, KPMG. They keep doing a lot of research and keep publishing their data. Now many times for estimating the resources, you don't know what need to be done, or I don't have enough experience to use my experience for estimating. In such cases, I go with the industry or company wide or whatever the data which is made available, which is published by other companies or within the company also. So I rely on the published data because I don't have any experience, neither I have any data which can help me to estimate. The bottom up estimates talk about estimating at the activity level and then summing up at the higher level. Okay, give me a moment. Okay, so the bottom up estimates are like that you have a work breakdown structure, something like this, and you have identified activities for it. Now you estimate this will take 5 days, this will take 2 days, this will take 3 days, this will take 1 day. Now this is take 2 days, 3 days, 1 day, 1 day. Now you sum this up, the time required or the time required for this, if they are all in sequence, then 11 days, and time required for here is 7 days if they all are sequence. If they are in parallel, maybe it will be different. Then we sum this up at this level and say total time required for this project is 18 days. So this is the bottom up estimate. I think you might have used several times for such kind of thing. There is project management software, there are project management software that can help you in estimating the activities and helping with any of these techniques. What we get is the resources required for each activity, that is an output, and a relationship among the resources, resource breakdown structure, RBS. Okay, let's look at this. You may be wondering, what is resource calendar? Resource calendar is the availability of the resources. That is when the person is available for onboarding, if he is going on leave or is not, or he has committed assignment on some other project. So what time the resources are available. That is the resource calendar, availability of the resources. Right. So now in this process, you get an aggregated list of all the resources. All the resources required on this project. If you use a bottom-up technique, you will get to know that how many resources of what type are required on this project to accomplish all the task, all the work. It includes the type and the quantity of each type. Right? Now, what you have a network diagram, you have the resources available to you. Now, this is resource breakdown structure. It means a hierarchical, say you say PM here, then he has say PL, then another person say architect, then say another person technical lead, then PL has some resources under him, TL has some technical resources under him, architect have some designer, draftsmen under him. So that is what the resource breakdown structure is all about. We can also do it like at the first label resources, then we first divide into human resource, material and the cost. Then under HR we can do this hierarchy, we can present this hierarchy, human resource. In the material we can say what kind of material we are going to procure. So steel, cement, so we can divide this into this. So even material can be done, and the cost, what type of cost resources we have in our project related to money something. Now when we have network diagram as well as resources available. So when we have identified how many resources for required for or how many resources are available for a particular activity, then we can easily figure out how much time it will take. So suppose I have this work to be done, I have 2 resources and this can be done in 5 days. Now suppose you get only 1 resource out of it. So then the duration will increase to 10 days, right? It could be more or less, little bit. But this is how number of resources actually help us to identify or calculate the duration of each activity. So there are various methods of estimating the duration. The first one in that is the analogous estimate. The analogous estimate. Now what is the analogous estimate? Analogous estimate is that, anybody has any idea what is analogous estimate?
The expert judgment, like gut feeling kind of, how much time this will take, person who has experience.
That is expert judgment.
Yeah.
That is expert judgment. Expert judgment means is the opinion of an expert. So he takes all the activities and start putting based on his experience how much time it will take. That is expert judgment. What is analogous?
With the historical information. Expert judgment with the historical information.
Okay.
And based on that.
Okay. Any other opinion?
Well, I'm thinking of analogous as an opposite of digital in as we say in physics.
Right. But
so yeah. Analogous means something which is not discrete.
Okay.
So that means it cannot be quantified in real absolute numbers, but it is approximation.
This become a little technical definition here.
In my opinion, analogous is very similar to, in the history, is a similar type of project if there is.
Right.
So we can consider that.
Correct. It is similar to this. In fact, in the analog and digital also, Analogous come because the pattern is similar. So analogous
Yes.
basically talk about it is similar to something. It is analogous to someone. So in the analogous, it is something like you have done a project P1 in past. You have already completed it. Now you are doing a project P2. Now P2 is very much similar to P1. So whatever experience I have on P1 or whatever the duration etc. I have taken on P1, I can use here to estimate P2. Right? This is past project. Now it becomes a history. So historical database, this information is available, and this is future project. So what I do, I see that if I am doing a project today, if there is any similar project has been done in past. If so, I try to see how much similar they are. If they are very much similar, I can apply analogous estimate. If they are not so similar, analogous estimate may not be a right fit. It is only fit when you have a similar project in past. What is the accuracy level? Accuracy level depends upon how similar P1 and P2 are. More the similarity, better the estimates. Less the similarity, worse the estimates. So it is one-to-one comparison with one project in past. One-to-one comparison. It is not many-to-one. It is one-to-one comparison. It is not many-to-one. So I have to find a similar project in past, then only I can apply analogous estimate. If not, then I cannot apply. There is something called parametric estimate. Now parametric estimates are also based on history. Anybody has any idea? What is parametric estimate?
I mean, it is based on experience, but the variable change. For example, it is a similar project, but the volume is bigger. Something of that sort.
Not as such. Any other opinion?
I think it is as per the name, it's based on some parameters which we derive.
Yeah, it is parametric, so it is based on parameter.
So maybe we can have some parameter values for based on the previous project, and then we use those parameters to drive to get our estimates.
Yeah, it is mainly formula based. Parameter, there are parameters, so there are few variables, like as Prakash said, there are some variables here, and as you said that it is based on parameter and then equation or some calculation among the some kind of formula.
I'd like to give an example. Sorry.
Yes, I was saying, like time per line of code.
Per line of code.
Yeah. Kind of estimation.
Okay, so you have some efforts per KLOC, right?
Correct.
Some benchmark figure you have, or some published figure is there for per kilo per 1000 LOC. Okay.
Yeah. Or a similar example in some other industry would be, let's say, I have experience of building a 1 kilometer long bridge, but I have to build a 2 kilometer long bridge of the same width. So it will probably be twice the effort.
Okay.
So something of that sort. This is just an example.
Yeah, this can also be a little broader terms. Yeah, this can also be applied. Yes.
Or it can be like in software terms, say we know, like say the program software which we have to develop is, say, which you have already said, say so much line of codes, and on the experience we can say, if we say key resources can put if so many resources are available, and they are putting, so how much time they will take to put this line of codes.
Okay.
based on that.
I explain this way. Suppose you need to paint a room. So what you normally use? You use how many days it will require. It depends upon the surface area of the walls,
Yes.
right? And productivity divided by number of resources, right? Number of resources, correct? So if area is 100 square feet and productivity is 1 square foot per person, and their number of people are 5, then it can be done in 20 days, right?
Yeah.
Correct. So this is one way of understanding that how we can do the estimation. Now the whole questions come from where the history come into picture. I said this based on history also. History come into picture with respect to productivity. From where the productivity comes. If you call a painter, he knows that what is the productivity of his painter, his labor, or his person, his team member. How he has judged that his productivity. That person has no mathematical way of doing it, but he is applying some mathematics, though it is not so formal. What he is doing, he is over a period of time, he has watched these people on in various circumstances and various projects, whatever he has taken in past, he has observed them and has calculated has a gut feel that these people normally take 1 square foot per day. Oh yes, 1 square foot of area to paint per day. Now how we normally do it? We do it this way. We do use a regression analysis, and we look at the projects we have done in past. I'm not talking about one project, I'm talking projects. So when I do and identify relationship, so this is called regression analysis. In this, there is a parameter X, there is a parameter Y, and I normally put up dots here based on my experience on various projects. So in one project this, when X value is this, the Y value was this, and I keep doing this. Some weird patterns also come, but I normally try to see what is the pattern. So if you see, the pattern looks like this. That shows that as X increases, Y decreases. As increases, X increases, Y decreases. There is a relation between X and Y. Now if I replace X with size and replace Y with productivity, what I am doing in the past projects, I am saying if the project was this size, the productivity was this much. If the project was this size, the productivity was this much. Based on that, I have put up this line. Now this line equation will something like come like that, as productivity is equal to size into 3 plus 1, something like that, or 3s plus 1, or 3s square plus 1, something like that will come, or minus 1, or whatever it is, right? It is decreasing, so maybe it is root can come and -5, something like that. Now if I now look at my project. I see what is the size of the project. Size is the area. Looking at the area, I put the area, I get the productivity. This productivity I applied here and use this formula. So this productivity actually is required to calculate the productivity. We need to look into various projects in past. More the number of projects are, better our equation is. So if we are only comparing 3-4 projects, our accuracy level will be low actually. But if we are using 200 projects in past, if we are studying 200 projects and mapping here, then our equation will be much more perfect and much more generic in the way our organization works. And that manner, you get better accuracy with respect to the productivity. What you are trying to judge, that on this project, what will be the productivity of my people. Got it? So this way, parametric estimates are formula driven, plus they are based on our experience on past projects, not projects, many projects, multiple. More the projects we study, better our estimate will be. Right? Now something group decision making techniques comes. Why it is come? Because these estimates, more than one people can be involved. If there are more than one people can be involved, you need to use some kind of decision making techniques to arrive on a final outcome. What is reserve analysis? Reserve analysis says during this timeline, if your project is of 50 days, have some reserve, say 5 days, 10%, let's say. Have some reserve and then distribute this reserve at in appropriate places. So that you not only deliver milestone on time, but also deliver the final project on time. So this reserve analysis normally say, looking at the risk factor on the projects, you can assess how much buffer you should have on this project, and then managing the buffer, continuously looking at the buffer, how much buffer we have consumed and how much is left over. This is reserve analysis. We do the reserve analysis in our costing part also. We will look into the next chapter. What about 3-point estimates? Anybody any idea? What are
just
yes?
Yeah, Amitabh here. This reserve analysis, do we have any technique? Means how to determine this buffer?
It is not. It should be based on the risk profile of the project. So if risk profile is average, you can go with the average allocation of the buffer, probably 10%. Some companies have 5% based on their own data. But 10% is normally a good buffer in an average risk profile, with an average risk profile. If the risk profile is higher, you may need a higher buffer. While it's low, you can manage with the low buffer.
So this basically buffer we add to the total duration, or we apply it to the in different parts, or
total duration.
How we apply this?
Total duration. Always add buffer in the final estimate. So means you have several activities from here to here, 5 days here, 2 days here, 5 days here, 3 days here, 7 days here. Total come out to be 50 days. Then you take the buffer of this, 10% of this, 5 days. The total duration become 55 days. So you announce the customer 55 days, not 50 days.
But okay, that is understood. Now, when tracking the activities,
yes,
should I distribute this 5 days across the activities and then track?
Normally, we recommend distribute this buffer on important milestones. So put some buffer just before important milestone. So in case of any delay, you can manage that.
Okay.
It is because,
So proportionally we can divide.
yes, it is because if you deliver milestone on time, it builds the confidence in stakeholders. So suppose you have put one day here, or say 2 days here, and 1 day here, and 1 day at the end. Now if you face some challenges of 1 day here on this milestone, you are still good. If you face some challenges during this time, up to 2 days, you are still good. Right? So you keep delivering your milestone on time. Now look at the scenario where you have 50 days plus 5 days. Now what is happening? You have missed this milestone, you missed this milestone. What do you think after half project is done, you have missed 2 milestones? What will be the confidence of your stakeholders? Even if you tell them I have enough buffer, I will deliver on time, will those people really believe you? People don't believe on words, they believe on deed. If you deliver, they say, this is going fine. And if you keep saying, who believe on what you say? Therefore, distribution of the buffer in appropriate milestone is better. Right? What are 3 points estimates? What are 3 points estimate?
The average of most likely what the time will take, then optimistic and pessimistic summation of this.
Right. So this is yes. So this is what the 3 point estimates is. Now, if you look at the expert judgment estimates, what happens? You give the activities to an expert and ask that what are your estimates. They will give you estimates. If you give this list of activities to 10 people, probably you get 10 different estimates, because everybody's experience is different and they estimate differently. To balance the bias of the expert judgment, this technique is quite useful, because we don't ask for one estimate, one magic figure, we ask for 3 figures. It's a most likely. Most likely means normally what expert judgment is estimating the activity it is most likely one. Then we ask for optimistic and pessimistic. Now what is optimistic? We ask people that you look at the activity and see what can go wrong, and assume that everything goes smooth, nothing goes wrong. Whatever you have estimated, suppose you think 2-3 things which can go wrong on this activity, but now assume that none of this going to happen. Your activity will happen without any problem. That is optimistic. Then we go to the pessimistic. Now you consider that whatever wrong or can go on this activity will go wrong. Whatever risk is you have identified will materialize. So you look at the worst condition and estimate how much time it will take. So optimistic is the best conditions, and the pessimistic you are estimating for the worst condition, and then apply this formula. Now this formula has optimistic plus 4 into most likely plus pessimistic, right? Now that means we are still biased towards the most likely. We want to remain near to most likely, but we also do not want to totally forget about optimistic and pessimistic. So we influence the expert judgment estimate with worst condition and best condition situation. Therefore it is also called weighted average. Weighted average. Why it is weighted average? Because this has higher weight than optimistic and pessimistic. So this gives us the duration estimate. Now we are not satisfied only with the duration. We also calculate the standard deviation. The standard deviation is the higher limit minus lower limit divided by number of incidences. So number of incidences are 6 here. Higher limit is pessimistic, lower limit is optimistic. Minus and divided by the number of incidences, that is 6, and that's turned out to be standard deviation. We also calculate variance. Now why we calculate variance? The reason behind calculating variance is that we cannot add the standard deviation. For example, there is an activity A, activity B, activity C. Here I estimated the duration, say 7 days. This 7 days has come with optimistic plus 4 into most likely plus pessimistic is equal to duration. This activity has come as 5 days, this come as 6 days. Now I calculate the standard deviation also, P minus O divided by 6. Suppose here it is, standard deviation is, this is duration, this is standard deviation. Say 3, here it is 2, and here say 2.5. Okay. Now when the activity will finish? Activity will finish somewhat between 4 to 10 days. Means D plus minus sigma. That is the duration. So we do not give a magic figure, we give a range. This activity will finish somewhat between 4 to 10 days. This activity will finish somewhat between 3 to 7 days. This activity will finish somewhat between 3.5 to 8.5 days. But if I say if A, B, C are in sequence, if A, B and C are in sequence, how much is the total duration of the project? In the total duration, I can sum the duration, right? So it becomes 18 days, but I cannot sum this standard deviation. What I do, I take the square of this, which is called variance. So what is the square of 3? 9. Square of 2, 4. Square of 2.5 is somewhat 6 point something. Let's say 6.5. Right? And the total of this, $19.5, right? Now 19.5, and we take an under square root of 19.5 because why? Because standard deviation is square root of variance. When variance is square of standard deviation, therefore standard deviation is square root of variance. So I take the square root. it will somewhat come out like 4.5. So the standard deviation here will come out to be as 4.5, not the summation of this. And therefore the project will finish somewhat between 13.5 days to 22.5 days. Is that clear? Any confusion? Any question on this?
Yeah, I have a question.
Yes.
I have a question.
Yeah.
What this number 6? I couldn't understand this. Where did this number 6 come from?
Number 6. You mean to say which number 6?
Yes.
This?
Estimated duration, everything divided by 6.
Oh, this 6. Because 1 plus 4 plus 1.
Yeah.
6 only.
Okay. Yeah, it's a weighted average.
Yes,
right?
yes. So
okay.
O plus M plus M plus M plus M plus P.
Okay.
Therefore, there are 6 incidences.
Okay.
Any other thing? Okay, so if this is clear, let's do this exercise. First, you have to calculate the estimated duration with O plus 4M plus P divided by 6. Then you calculate the standard deviation. Then you calculate the variance. Here, duration will be duration plus minus standard deviation. And here it will be, you cannot total this. Standard deviation cannot be total. You have to total, you cannot total this. You have to total this and then take a square root of this to get the standard deviation of the complete project. Got it? Five minutes are enough, or whenever you're done, just let me know. Okay, check with this. Check with these results and let me know if your answers are right or wrong, or any confusion with respect to answers. Okay, what is the question?
Okay, the question is that I can see it's finally our objective is to calculate the range deviation, deviation plus minus, right?
Correct.
So for calculating the range, all we need is an estimated duration and the standard deviation.
Right.
So why are we calculating variance?
How did you calculate this?
No, why? How? I know. Why?
Okay. You cannot add them actually. Standard deviation cannot be added.
But I mean, see, to get the range,
Yes,
okay, what I'm doing, I'm just simply adding and subtracting standard deviation from the estimated duration,
correct.
right? So why do I need to add them? I just,
What
why do I
about this
need
line? What about this line?
which line?
The total one.
Oh, okay.
Yeah, basically we cannot go with the standard deviation in case of total. So once we have the variance, based on that we'll go.
You have added this for total.
Okay.
You cannot add them. You have to take variance, add them, and then take a square root of this.
Okay.
Vivek, so otherwise variance is for the particular activity is may not required. Only when we go for the
For
total,
individual
that
activity,
time
it
we
is not
consider.
required. You are right.
Yeah.
Okay.
It is only required for the summation.
Right.
For me, there is one place I had a mistake. Otherwise, calculation perfect.
All is good. Okay, great. So such kind of questions can come up as such. Okay, now you have activity duration. You see there are group decision making techniques. We have discussed this. Now what you get, the activity duration estimate as an output of this process. So you get the estimated duration or estimated range, something like this. Or you can come out with the probable number. What is the chances of completing the project in this duration or exceeding by this duration or not able to complete this in this particular duration. So that probability you can forecast. So on this process you had got the duration. So you have duration, you have dependencies. You have duration, you have dependency. You have already a network diagram and now you get duration. Now you put the duration on the network diagram. If you put the duration on the network diagram, you will get your schedule, the primary schedule, preliminary schedule I will say. Preliminary schedule you will get. Now we have to work on that schedule, preliminary schedule, to reach to the final schedule and figure out what is the start and end date of the project. For that we use some tools, something like critical path method. So critical chain method, resource optimization, some modeling techniques like simulations, etc. We can apply leads and lags. We have already done it in the dependency determination, and then the schedule compression techniques. So schedule compression techniques are used when schedule is longer than we want. Now schedule is very important part of the project. If you see the list of inputs, look at the list of it. Schedule almost touch every part of the project, almost touch every part, and this is the most changing artifact on the project. We normally say if you have opened the schedule, there is a high likelihood that you will make some changes. The only way not to make changes is not to open it. It's the most changing artifact on the project and continuously required optimization and controlling. So critical path method, resource optimizations, schedule compression techniques are the ways to reach to the optimization and get the final schedule. So what is critical path method? What is a critical path?
the smallest duration to complete any task.
Okay.
Longest duration to complete task.
Longest duration.
To complete activities or complete a task.
Okay. It is the longest path.
Yeah.
The longest path on the network diagram to complete the project, and is the shortest duration a project can be completed.
So
The longest path, but the shortest duration project can be completed. Project cannot be completed less than this time. How do you calculate critical path? Basically, we calculate float on each activity. And what is this float? What is the float? What is float?
lead and lag.
Float is lead and lag? No. What is float?
Float is basically, say if we are doing two activities and it is the extra time which is available. On they say the two activities can be done on two different ways, or there are two different paths. So one path may be done say in say 5 days, another can be done in 7 days. So there is a float available of 2 days.
Okay, yes. So it is something like this is A, this is B, this is C, and this is D. Your network diagram is like this. This is 5 days, this is 6 days, and this is 7 days, and this is 5 days. So what is the critical path? 5 plus 7, because this is the longest path. This become critical path. So 5 plus 7 plus 6 become 18. But if you see this path, this duration is only 16. Correct? This path is 2 days shorter than the critical path. That means if I delay the completion of C by 2 days, there will be no impact on the project end date. If I delay the C activity by 2 days, 1 day, maximum by 2 days, there will be no impact. The project will still finish in 18 days. And this free time available on C is called float. So how much float is available here? Is it 2 days. Now, as soon as C delayed by 3 days, more than the float available, the critical path will change. Suppose this is delayed by 3 days, 5 become 8. Then this path will become critical path and the duration will be 19 days. And this B will be having a 1 day float. So during the project happening, the critical path may change depending upon the faster or early things are happening. Suppose B finishes faster. You can finish in 1 day early. You can finish this in 17 days. If it is finished 2 days early, you can finish in 16 days. If it is finished in 3 days early, instead of 7 days, you complete it in 4 days. Your project will still take 16 days. At that time, this path will be again be critical. Right? So what we do to calculate the critical path, we calculate the float on each activity. We calculate the float on each activity, and figure out which activities have zero float. If you see, the float on this is 0, float on this is 0, float on this is 0. But this has a float of 2 days. So we calculate, we see the activities that have 0 float, and you connect all those activities that have 0 float, you get the critical path. Let's understand with this example. So there are some other terms also like free float, project float. What I talk about was the total float. What is free float? Free float is something like impacting the next activity. That delay of C will not delay the D. So in this case, if C is delayed by 2 days, D will not be delayed. Therefore, here the total float is equal to free float is equal to 2. But if I add an activity here as E, then the free float on C will be 0, because as soon as C will be delayed, E will be delayed. So total float is 2 days, but free float becomes 0. But to get the critical path, we do not calculate free float, we calculate total float. And the project float is the float which is normally we put a buffer at the end of the project. That is the project float. So let's understand with an example how we calculate critical path. Now every node, if you see, every node has 7 parameters. One is duration, this is duration. One is float, early start, early finish, early start, early finish, late start, late finish, and the name. So this activity D, look at this, the duration is 3, F is to be calculated, ES, EF, LS and LF are to be calculated. So to calculate the critical path, what we do? We do a forward pass and then do a backward pass. When we do a forward pass, we calculate early start and early finish. When we do a backward pass, we calculate late start and late finish. Okay. Now let's see how we calculate. This is a start, so the D start from 0. The duration is 3, therefore it will complete on 3rd day. So early start is 0, early finish is 3. Now look at the next activity E. E will start at 3, right? Because D is finished on 3. And 9 is the duration, so it will finish on 12th day, right? Is that right?
Yeah.
Now look at this A. A start on 0 and finish on 6th. Now B has a contest. B depends upon there are 2 predecessors to B. Which one we should take? When we are doing forward pass, we take higher. When we do a backward pass, we take lower. Whenever there is a contest. So here it is 3, here it is 6, so it's 6. B cannot start until unless D and A both are finished. So therefore it will start on 6th. 7 is the duration, so therefore it is 13. Right? Now F also has a contest between 12 and 13. So therefore we take 13. 13 plus 6, 19. Correct? Stop me wherever you do not understand. Now it is 19. It starts on 19 plus 7, 26. What happened?
I think slide has changed.
Got it? There is some bug with GoToMeeting. Now it is, here it is 26 and plus 7, 33. Now look at here. This is 13, so it will start on 13 plus 11 become 24. So what is the duration of the project? 24 or 33? 33, because last activity completing on 33. So we'll take the duration of the project as 33 and do a backward pass. What is backward pass? Here it is 33, it is finishing on 33 minus 7, 26. Here it is 26 minus 7, 19. 19 and 13, correct? Now here there is a contest, so I will fill this first. This is 33 minus 11, 22. Right? Come over here. It is the contest between 13 and 22. Which one will take? We talk about when we are doing a backward pass, we will take the lower one. So it is 13 minus 7, 6, 6, 0. Now come over here, it is 13 and 4. 13 minus 9 become 4. Now here there is a contest between 4 and 6. So we'll take the lower one, 4 minus 3, 1. Let's calculate the float. Float on A is, but how do we calculate float? Float is either LF minus EF or LS minus ES. So LF minus EF is 0. This minus this is 0. This minus this is 0. Now come over here. 4 minus 3 is 1. 13 minus 2, 12 is 1. Here it is 0. It is 0 here. Here it is 33 minus 24. How much is this? 9. So what is the critical path? Connect all the activities with that have float as 0. So this is float as 0, this is float as 0, this is float as 0, this float as 0, this float as 0, this float as 0. So our critical path is A, B,
F,
G, H. Right? There is another term called near critical path. That means a small delay there on that path can make that path also critical. Which one is a near critical path?
Then
This one, right?
D, E,
Because the float is 1.
F, H.
Float is very less. The path which that has less float is a near critical path, because if D get delayed by 1 day, E become critical. If D is delayed by 1 day, E become critical. And this total float is normally available on the branch. So this branch, this side, this path, it is shareable float. So total float is normally shareable on the particular branch. Now what is this? This contains a lot of float. That means C can be delayed up to 9 days without impacting the project end date. Is that good?
This near critical path,
Yeah.
It can be like this D and then B and then F.
Yeah, basically DE. I will say near critical path is DE.
DE or DB, that's what I'm saying. Because basically
So B is critical, right?
DBFG.
B is critical.
Pardon?
B is anyway.
No. That's what I wanted to understand. Say the complete critical path, we are saying it is A, B, F, G, H, correct?
Yes.
This is the critical path.
Correct.
Now near critical path is with the nearest float, correct?
Yeah.
The minimum float.
Correct.
So there are not two. What I'm saying is in the total path, the minimum float, if I see, is D is having float 1, and then after D, B we go, it is a 0 float, F is 0 float, G is 0 float, H is 0 float, so on. So the complete path is having only 1 float. If we go for D and E, then there is a 2 floats, 1 plus 1, 2 floats.
No, this is what I'm saying. It is shareable. This float is sharing. A shareable float. As soon as D delayed by 1 day, this 3 become 4. It become 4 here. It become 13 here. This float becomes 0.
Okay, so you are saying, so near critical path can be DBF or DEG, anyone will go DEF and or DBF?
It is DE, because if you see between D and B, there is a difference of 2.
There is a difference of 2 where?
No, it is starting on 6th, it is finishing on 4th.
Correct. Okay.
Maximum, right? Otherwise it is 3 actually. So there is here, this, it's not a problem, right? Problem is here. So D and E, this branch is a problem, right? It has only 1 day float, this branch. This branch has 1 day float. That means if there is a D is delayed by 1 day, so this 3 become 4, this will be, so it will not impact the project, but it will make E critical, because the float on E becomes 0 as soon as D is delayed by 1 day. It will not impact B.
So if you take DB, in this case we have 2 days float.
Actually 3 days, but we can say 2 days. Maximum, if you say 4 between 6, it is 2. 3 and 6 is a 3 basically.
3 days, correct. Okay.
So basically this branch has no problem. The problem is on this branch, because it's a float of only 1 day. As soon as D is delayed by 1 day, E become critical, because the float on E becomes 0. If suppose D get delayed by 1 day, so this 3 will become 4, this 3 become 4, this 12 become 13. How much is the float? 0. So E also critical.
Okay.
And suppose D get delayed by 2 days, then critical path will change. Then these things will cut and this will become critical path, and the duration will increase to 34. Then the critical path will become D, E, F, G, H, and total duration will become 34 instead of 33. The idea here is that the path that contains less float also need to be watched carefully. See, now to complete the project on time, why we are calculating critical path? Because to complete the project within time, you need to carefully watch A, B, F, G, H, because anyone who get delayed, the project will get delayed. Right? But the thing is that you also watch near critical path, because near critical path is also dangerous, because as soon as any activity get delayed on near critical path, that can also create problem. Either the critical path may change or that activity can also become critical. So both critical path and the near critical path, both to be watched carefully, to be controlled carefully, so that you complete the project on time. Is that fine?
I think it's need practice to do this.
There is another concept called critical chain. Now critical chain is done on the critical path. First you identify the critical path. Now you might have seen that we only created the critical path based on duration. Suppose a non-critical activity, let's say E has some resource constraint. Even though there is a float of 1 day, don't you think E is also critical? Because there are scarce resources working on it. Any kind of challenge will make put E in problem. So what the inventor or the definer of critical chain says, that resource constraint critical path is critical chain. Put resource constraint also in the whole network diagram, and then create a critical chain, adding those activities which have scarce resources in the critical path. So resource constraint critical path is called critical chain. How to manage such things? He given suggestion to have buffer. Is a keep a buffer in the schedule and put them on strategic milestones and at the end of the project. So you say, if this is my important milestone, I put some 1 day buffer here. If this is my important milestone, I will, or suppose this is my important milestone, I will put 1 day buffer here and 1 day buffer at the end. 1 day buffer at the end, or say 2 day buffer on the end. So I have put the some buffer on a critical milestone. It also says that wherever a non-critical activity is feeding into critical activity, add some buffer there also. So like E is a non-critical activity, is feeding into F, which is a critical activity, put 1 day buffer here as well. To manage,
So we are near critical path also we are adding buffer.
yes, wherever a non-critical activity is feeding into critical activity. Now this helps us to
Critical activity. What do you mean by critical activity? Resource constraint?
Yeah, resource constraint or the float is 0 because of the resource or because of the float, both.
Important milestone. So if we have
Important milestone,
that is also.
yes, go ahead.
I was saying in the important milestones, especially when we see the that is a 0 float, so better to give some buffer there.
And what the things he suggests, that manage the buffer. Always look at the how much buffer is left.
Okay.
So you should not consume buffer before time, or keep a watch on the buffer. That will only give you the trust that how much delay can happen on the project. If you are consuming buffer at a faster rate than you're supposed to do, then your project end date is in danger.
How to determine how much, basically what is the total amount of buffer? Is there any rule by which we can say this on this project the total amount of buffer so much can be put, or estimation of total buffer?
As I said, based on the number of critical activities, the risk, because every critical activity has a risk of getting delayed. So the risk profile of the project, the scarceness of the resources, the number of activities on critical path, all these things add the factor on the risk part, and higher the risk, more the buffer you should take. Right?
Right.
Now another thing comes into picture is the resource labeling and resource smoothing. Have any idea what is resource labeling? Anyone has any idea what is resource labeling? And what is resource smoothing as well? So resource labeling is basically.
So what I understand is basically resource.
Go ahead.
The resource labeling is distributing the resources among the critical or among different activities of the project.
Okay.
So that we don't have one more resources allocated to one activity, and there are less resources on other activities. So it's a equally a proportionate division on the resources on the day.
Okay.
For the activities.
Okay. One more person was trying to explain this. What's that? Anyone want to add?
I think it's also related to.
You go ahead.
Yeah, I think it's also related to certain phases of the project. When during a certain phase, maybe all the critical resources are utilized to the optimum, and there could be certain other phases when all the resources are not utilized to the optimum. So trying to distribute and manage resources according to the best possible outcomes.
Okay. Look at this. This is suppose a window of 8 hours.
Yeah.
So in every day the person is available only for 8 hours. And this bar showing the allocation. So it is allocated less than 8 hours, is completely 8 hours, less than 8 hours, more than 8 hours, 8 hours, more than 8 hours, more than 8 hours, less than 8 hours, 8 hours, right? Now there is no problem here, 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 here. Now where we have a problem here, correct? The person has 8 hours, but he will not be able to complete his work because he is allocated more than this. And this is called over allocation. The resource is over allocated. He is allocated the work more than the hours available to him. This is called over allocation, and resource leveling is used to level the resources to remove this over allocation. So to press it down, when you press it down, the project goes in that direction, get expanded. So it is a kind of bulge which has come into the project. When you push this bulge down, the project extended on this. So what you do, this comes to the next day, then or get added to this. These two things will come on next day. So this will become 8 hours, this will become this, and this will become next. So one more day get added into this. Okay, so there is a space, it will get adjusted. If there is no space, then the project get extended. So basically, removing any kind of over allocation is resource leveling. It often increases the project duration. What is resource smoothing? Is adjusting the activities within the float to level the resources. Any kind of removing the over allocation by adjusting the activities within the available float. Okay, so that is called resource smoothing. It may not be possible all the time. Now modeling techniques, normally simulation.
So basically in the previous scenario here, in the same example which you are given, the resource leveling, you said you push those over allocation or more than the resources working for more than 8 days, we have to adjust, and then it may extend the period. Right. Now resource smoothing is what you are saying is, say whatever the extra more than 8 hours activities which they are doing, that will be allocated to some other resource, or how we can manage it within the float? Or it can be, is that?
See, float is an available time, right? So this over allocation, yeah, you can do a reassignment if possible, if required. Reassignment is possible, but you only use the available float free time to adjust this over allocation.
No, so what I don't at least that differentiation is not clear, because what I'm saying is, say in resource leveling also it will extend the time. If the float is available anyway, the project duration will not increase. In the first case, resource leveling also, when I'm pushing those things down, yeah, it will extend the time of the project if there is zero float. If the float is available anyway, it will not impact the time. If it is within the float, it is adjusted, correct?
Okay.
So that is resource leveling also. If I push the thing down, it may or may not impact the project and duration, depending upon if float is available or not available.
Okay.
So how it is how it is different from resource thing.
Okay. How much you have worked on Microsoft project or similar scheduler? Have you good experience on this?
On
Microsoft project or any other scheduler?
No, I have worked on Microsoft project.
Okay, so in Microsoft project there is an option. If you go into the resource tab, and in the resource tab there is a labeling option, and in that options, if you see, there is a option available that do labeling within the available float. Now many times what happens, that you have allocated a person. Now allocation of the person, maybe this is incorrect. Maybe the person is over allocated for no valid reasons. But when you prepare a schedule, this often happens. So it doesn't mean that it cannot be adjusted against the float. It can be adjusted. So there is a float. You can do reassignment also if required, but without reassignment also, Microsoft project look at the places where this over allocation can be adjusted against the float. So total float in the project will decrease, will come down. So what I'm saying, it is not what you are saying that if there is a float or if it is a float available, then why the critical path will come. No, what has happened?
No, so sorry. Maybe I have put it,
Okay.
I have not put it properly. Maybe actually, I am resource leveling, means I just wanted to know, basically I am not having a clear understanding of resource smoothing basically. What I am trying to say is resource leveling I understand. I am not able to understand resource smoothing properly maybe, because I am not able to differentiate how resource smoothing is different from resource leveling. That clarity is not coming to me. So basically I think my problem is I am not able to understand resource smoothing properly.
Okay. See, the thing is that resource labeling and resource smoothing are not very different. What we are doing resource smoothing, that we are doing labeling within the float only. So we are utilizing float instead of increasing the project length. And it has its own.
Okay, so what you are saying is only different is between resource leveling and smoothing is within when we are utilizing the float, and leveling is will extend the time.
Yes, yes.
Is this understanding correct?
Yes, correct. It's absolutely right.
So in other words, resource smoothing is just a part of resource leveling. If you are doing resource leveling when there is no float available, then it is resource. If there is a float available, then it is smoothing. Otherwise, it is leveling.
Correct. So resource smoothing is also a resource labeling, but within the available float. So overall float in the project will come down.
But if in critical path there is no float is available, and if in such scenario comes, so in that case, whatever the way, whether we go leveling or smoothing, the duration will increase.
Yeah. So it is not always possible also.
If
In
we
fact,
only
I think
then only we can do this.
So it is not always possible. It has its own limitations. So it is only in some circumstances used, and don't think that by using float we should be very happy. You know, if a project has very less float available in the project, this project becomes very risky.
yes.
So it has its own limitations. So most of the time resource labeling only used. Resource smoothing is used in a very rare any very selected circumstances.
Yes.
Mostly it is resource labeling which we normally use.
But in case of leveling also, if we are in critical path and have the zero float, in that case also it will increase the duration
Yes, it will
and cost
increase the
as well.
duration. That's what I'm saying. Whenever you do resource labeling, chances that it will increase the duration. In 99% cases, you will get an extended duration.
So what is industry standard for the keeping the this float or buffer is generally 5 to 10% or something else?
No, it is not like that. You don't keep the float. It is available due to situation in the project.
Okay, nothing is standard, industry standard.
There is no standard. We normally say don't kill the natural float in the project. It is the float is normally naturally, but because of the dependency and the duration of the activities. So it comes naturally. Now resource smoothing can tighten the tap. So we say.
No, I was talking about keeping the buffer. So the buffer will help me to keep the float.
The float is not buffer. Buffer is an additional time. Float is available. I say this A, this B, this is C and this is D, like this. C is 7 days, this is 5 days. So this 2 days of available time on D is naturally available because C is longer than D, and A and B are the predecessor for B and C both. So this 2 days of float is available automatically.
Then
Naturally available.
Correct.
So float is
So,
not buffer. Buffer is
what
something you add into this. So you add one day here, which is not a natural buffer. You are adding natural available time. You are adding time availability. That is a buffer.
So in this context, say in this example which you have given A, B, C, D, the network which you have drawn, say if I have to do resource leveling, my understanding is if we generally go, as you said, you generally go for resource leveling. That means if we have to adjust the over allocated resources, we will follow it on the path ACB, which is having 7 days, so that the project duration will increase, correct?
No,
Instead of doing it on a ADB.
Suppose there is an E also here, and there is an over allocation here. You say,
Okay.
instead of extending the time here, you adjust this over allocation against these 2 days. So this 2 days will come down, and your E will not be over allocated. Otherwise, if you don't choose this option, this 2 days will stay there, and this will go ahead. Actually, in this case, it will be automatically done actually. But in many cases, it may not be done. In the case of C, if there is a delay, suppose there is a F here. If there is an over allocation, it is bound to increase the duration of the project.
Yes, in the critical path is bound to increase.
Yes.
If it is in critical path, definitely bound to increase the duration.
Correct.
Because critical path itself will take where we have zero flow.
Yes.
Any over allocation, any resource unavailability,
Yeah.
to decrease the total duration.
Correct. So resource smoothing has its own limitations. It is not possible all the time. So if there is a 5 days required to smooth and 2 days only buffer available, you will not be able to do it actually. You can only do up to 2 days of over allocation. Otherwise, it will not be done. So normally this is not a very not a very good choice as such. Means not always used. We are normally using the resource leveling.
Yeah, so basically when in this case, the 2 days what we are using to leveling. If we have required for 5 days, we will not be able to do the smoothing because 5 days cannot be adjusted.
No, it will not be adjusted. That's right. So only do that much leveling which is possible within the available float.
Okay.
That is what it is. Right? Then we have modeling techniques. Either you say what if scenario or simulation. Both are simulation. So what if scenario is also simulation. Simulation means there are 3 ways scheduling is possible in a project. You do complete scheduling end to end in 3 days, 3 ways. That is called simulation. And figure it out which way scheduling will be good. All simulations are effort intensive exercises. Lot of efforts are required because you are doing end to end scheduling for a project 3 times, 4 times, 5 times, and then identifying which schedule will be right for me. More than that, what you can figure it out is that what is the probable budget in which I can finish the project. Out of 5 simulations, you have in 3 you are reaching to a particular budget. You can say this budget is most likely I will finish in this budget. Second thing, duration also. What is the most likely scenario of completing the project in a specific duration. So you will come to know that within that duration it is the most likely I will finish the project, because majority of the simulations or iterations are actually leading to that nearby that duration. So you can find out to complete the project within a specific date, a specific duration, or a specific cost. Plus also you can find out criticality index of an activity. What is criticality index? The probability of it happening on the critical path. So there is an activity. In all 5 simulations, it is on critical path. Its criticality index is very high. If there is an activity which is in 3 schedule, it was on critical. On the other 2 schedule, it was not on critical. Its criticality index is little lower. So criticality index means chances of happening that activity on the critical path. So simulation is lot of efforts are required, but we get to know a little more about the project and more clear data and better confidence on the project execution. But definitely it is required much more efforts. Leads and lags we have understood. Now we talk about crashing and fast tracking. Suppose your project you developed come out to be 7 months and you want to complete in 6 months. What do you do? Right? This is possible, especially when the dependency is discretionary. If this is 5 days, this is 5 days, I will save 5 days here by doing A and B into parallel that were in sequence earlier. This is only possible if this dependency is discretionary dependency. Mandatory dependency cannot be changed. So either I do this or I take a lead, 3 days lead. So I save 3 days here. This is called fast tracking. The activities that were in sequence, now we evaluate to do them in parallel or take lead on that to save time. That is called fast tracking. Please remember these actions are taken on critical path only, because only critical path decides the project duration. Doing such activities on non-critical activities have no benefits. It will increase the float. What is fast tracking? What is crashing? Crashing means there were one resource on this, I added another resource on it. So now it will become, this is 5 days, this will become 2.5 days. So I saved 2.5 days here by adding additional resource. So when we add resource and reduce the duration of the activity is called crashing. When we decide to compromise the dependency, the things which were in sequence now we do in parallel, that is called fast tracking. Both have their own disadvantage also. Fast tracking, because of compromising this dependency and doing this activity before or taking a lead or doing in parallel, we compromise the reason for keeping them in sequence, and that therefore it increases the risk on the project. And very clearly on the crashing part, that we add the resource, therefore the cost increases, project cost increases. So if you do crashing, cost increases. Into fast tracking, risk on the project increase. But you can get some time, you can On some activities you can work on, you may take out, you can reduce the project by 1 month.
But in case of fast tracking also, won't the cost increase? Because suppose we are using the two activities parallelly. So if you are doing the sequence, then might be the resource which we are utilized for the activities 1 can be utilized for the activity 2. But because we are doing the two activities parallelly, we need a same number of resources for both the activities to complete on same time. So in this case also the cost will increase.
Such activity you may not be able to do in parallel if the same resources are being used.
Okay. So basically in this case, not only the critical part, apart from that we need to take care the resource as well.
Feasibility.
When we're doing the fast tracking.
Feasibility also. There discretionary dependency, but not necessarily. If you have only one resource, then he cannot be able to do two. So in the case of one resource, you have this dependency is almost mandatory. If you get another resource, then this dependency can be done in parallel. But when you add the resource, it will increase the cost of the project.
And when we add the resource, it will be called as a crashing, not the fast.
Yeah, when we add the resource, there are two ways of adding the resource. So you can add the resource here also, or add one resource for here and one resource for here. So that is also a kind of crashing, though it looks like a fast tracking. So in the second case even worse, because both the things will happen. You will compromise the regions as well as increase the cost of the project. So both the losses will happen.
So yeah, in fast tracking both the losses there. Whereas in crashing
No.
The cost
Not necessary A and B require same resources. If that is not the case, then there is no problem with respect to cost.
Okay.
If A and B require different resources, then you can do it in parallel, right?
But that will again happen where we have discrete dependency, we cannot do this.
You can only do it when the dependency is discretionary, means you can change it. It is not hard dependency and the resources are different for A and B. So you cannot do at will. This is a situation in the project. You have to do it with respect to that only. So where you can do, you have to find the feasibility, where the changes can be done. So you have to watch from begin to end, complete critical path and figure it out what you can do, where the dependency can be changed, where the additional resource can be added. You cannot add the resources anywhere. It has to be feasible, right? So we need to check the feasibility as well as the feasibility of doing things, of doing crashing and fast tracking. Only then you can apply. So it may not be possible everywhere. Right?
Yeah.
So you, as an output, you get final schedule, which is baseline. Right? Final schedule, baseline, and the data which can support our schedule. And the last thing is controlling the schedule. And controlling schedule and developing schedule are not so different, except that you have to do the controlling schedule on a regular basis. So what you do in developing the schedule, same thing required in the controlling the schedule. Only thing is that you have to do it on a regular basis, plus you do it to address the delays and things be getting done early. So delays or advance to address that. So what you get work performance data, that is the execution data. Against the plan, you do plan versus actual, find out the variance, and to reduce variance you put up a change request which is an optimization or change in the schedule. And based on that, what the changes you make schedule forecast. We will learn in the earned value management in the next chapter that how we do schedule forecast. If you look at the tools, they are all same except the performance reviews. The performance review means doing plan versus actual, providing this information, identifying the variance, making a change request in the schedule for addressing the variance, and also making the schedule forecast. This is what, so whatever like leads, lags, changing leads, lags, changing dependencies, adding resources, removing resources, adjusting the resource labeling, doing resource smoothing. All these activities need to be done in controlling the schedule based on how much variance is there. If there is a variance, you have to do it. Otherwise, there is no variance, then well and good. Keep going on. All other activities are same. So in the
here when you are saying the change request, is the change request in the schedule?
Correct.
So it's more of an internal thing, correct? Basically for project manager purpose.
PMI changes are not external. PMI change requests which we are seeing in the as an output of these things, they are not external change requests, not in change in scope. It is change in the existing plan.
Okay, so only the change request which we have seen in the scope during the scope management, that is the external one, correct?
No, that is the change request which is coming into the integrated change control system, change control system. That is the only change which is change in the scope. There is a
integrated
change control process, right?
Correct.
That addresses the change in the scope, or it addresses these changes also. Any change there. But these changes which are being suggested as an output to various processes are internal changes. They are preventive actions, preventive action, corrective measures, and the defect repair. They are not change in scope. It is not same as change request we normally use in our day-to-day life. Our change request means change in scope.
Which we refer to as the integrated change request management as a part of integration. Right?
Yes, and including this change request also. Including this change request also. Corrective, preventive measures and defect repair are also be treated in the same manner in the change control system. Their change request is change in scope, change in corrective measure, preventive measure, or defect repair, or change in scope, new addition into the scope. All this are part of as goes as a change request input to the integrated change control. But these outputs do not suggest any change in scope. They suggest basically taking corrective measures. Now, corrective or preventive measures may go ahead with the additional work in the project also, may lead to, but not necessarily.
So just trying to put all the things in perspective. What I am understanding, or tell me if my understanding is correct. We have one is the integrated management, where we have the change request, integrated change request, where we are saying all the change requests will go, including this one, correct? Which are more of an internal thing.
Right.
Now, also there is a change request pertaining to which we say scope.
Right.
Which is basically they say if any new functionality has to be added or something, which is any change request where we have to get approval on the scope of this thing. So that also is a part of integrated, but this integrated will take care of everything. Only thing is that scope related thing where we have to get approval from the say stakeholder for the scope, for changing the scope, correct?
Yes. So like here, let me explain this. Corrective actions, preventive actions, and defect repair. These are the normally called change request in PMI terminology. Okay. Now, additional work in the project is also a CR, which are normally we term in our normal projects. Okay. Now, when we are making it integrated change control system, it is either of the CR, either these three things or additional in the scope. Anything will be there, they will be treated in the same way. Now the change request coming as an output to these processes, like this process, every control process has an output as in change request as an output. So this is corrective action, preventive action, and defect repair. Now corrective actions or preventive action may lead to an additional work in the project as well. Can lead to a CR, which we normally term in our projects. Corrective actions is not necessarily within the project scope. It can say that you have to add some scope in the project also. This is possible.
Agree, even
but not necessarily.
This year, correct.
But not necessarily.
Even the defect resolution, it may lead to duration and change request. But correct, this is not necessary.
Yes.
But it will impact.
Yes, it may bring additional scope also. Therefore, it goes the same way in integrated change control as anything else. So any change, this thing, say CA, PA, the corrective action, preventive action, DR and CR. Let's say normal, this CR means normal CR. Normally we call it change in scope.
Change in scope.
Yes. Right?
But when we do the corrective, preventive and the defect resolution, in this case also we do need to go back to change control board, or this is more on the project manager to manage these things?
Probably you can put the guidelines that what kind of changes will go to change control board, what kind of changes are not required. Maybe give a change control board
and the project plan
delegates authority to project manager. You decide on that.
Correct.
This is all about the process you prepare for your projects.
Mm-hmm.
Right?
Yes, yes.
And then, yes.
Yeah, like for instance, in other projects, what I did was anything that requires more than 4 hours of man hours goes to a change request. Otherwise, it is not.
Probably you can
Something
write,
of that
you
sort.
can write some kind of rules. Such, yes.
Yeah.
Okay, let's come back to this. Here the performance review. So performance review means you do like some critical path method. You use the EVM also. For that purpose, we will learn about how to use EVM and how if the schedule forecast and schedule performance index or schedule variance can be calculated using EVM. But we will learn this in the next chapter. We must use some resource optimization techniques like resource labeling, resource smoothing, and other things. Modeling techniques like simulations, leaps and lags, schedule compression techniques like crashing and fast tracking. These are all things same as in the developed schedule we discussed. As an output, you get work performance information, that is plan versus actual, or the schedule variance, schedule performance index, and forecast. Schedule forecast, what will be the completion, or when the things will be completed in terms of duration or date. A change request in case any change in the schedule is required to address the variance. This completes your time management. Okay, so kindly attempt the questions, and when you are done, please write down this in the chat box. I said that please attempt the questions for time management.
Yeah.
Page number 292. Okay, so let's get started. Let's go for question number 1. Okay, what about question number 2?
Yeah, this question is a little bit confusing, this question.
CBB, okay. You are measuring the project progress and found that float on one of the activity is negative. So what is float? Available time by which an activity can be delayed without impacting project end date, right? So what the negative figure actually represent? Positive figure available time, negative figure unavailable time. That means the time which is lost. We are delayed. We are delayed. That is the activity. So some activity is supposed to happen sometime, but it is get delayed and it is impacting the project end date. So negative -2 means we have to catch up 2 days to deliver the project on time. Right? Make sense? So what we need to do?
Yeah.
See, there are
It
two,
looks inform.
B and C.
Yes, between these two.
B will not help actually. See, you can inform stakeholders, but how it will help? Cannot we add resources and get the job done?
But if we add the resource, the cost will increase.
Yeah, but work has to be done.
Ask for more time.
No.
No.
No. No, but actually to add the more resources, because it's impacting the cost, which has to be approved by the stakeholder. So first thing in my view is, first we have to inform the stakeholder, get his concurrence, and then we have to add more resources.
See, let's look at the options. Ask more time to complete the activity. That means you say B is same as A. Inform stakeholder that the project will be delayed. Asking more time means it will be delayed, right? And C is add more resources. D is take out some resources. That is not possible, right? So only A, B, C. A and B are same. If you see A and B, you are asking for more time means your project will be delayed, right? So, and it is what is saying, inform stakeholders that project will be delayed. You are telling them the decision that project will be delayed without even attempting to complete it on time. You are not seeking help.
Yeah, the only concern what I was thinking here, so if we add the resource, it will increase the cost.
Right, which is fine.
In that case, we need to inform and take the permission from the stakeholders. So they ready to give the funding for that?
Yeah, you can inform your analysis and ask for resources. but what we are communicating is delayed.
Yeah.
You are communicating the project is delayed, then you are not looking for more resources. Basically, you are just telling that it will be delayed.
No, but basically the purpose behind the informing is to get the approval for the costing increase. No, I think because this is based on our thinking, because we had a similar question like that in the previous exercise also. We are for one of the things when we attempted the question during discussion, we said ki, if we have to impact, the first thing which has to be done is to inform the stakeholder, because we cannot add simply resources by our this thing. This has to be approved by the stakeholders and the proper.
The matter is that what you are conveying, what information you are giving to stakeholders. In that option, in that example or question, it was the analysis which you are presenting to your stakeholders. Here you are not presenting analysis and looking for more resources to complete on time. What you are...
No, I understand that. I understand. What I am saying is it okay if I, without the concurrence of the stakeholder, I of my own add resources, then who will justify the cost? If say going forward, basically without any concurrence of my own, I cannot take a decision to add the resources or do something. It's always better to first inform and then take the concurrence and do whatever action is required.
Yes, I agree with you. I agree with you, but what you will convey? Here the B option is conveying delay, means there is no need for additional resources, because the information you are conveying.
No. What I'm saying is, say when we are informing the stakeholder, we'll say this project is delayed because of these things, and the option is to add more resources. So if we have to complete on time, we want the approval to have more resources to be put on the project.
That is what you are saying is an analysis.
But if you go for C, the C is talking about the action.
Yes.
So action is not only the analysis. After analysis, we understood that the project is getting delayed. So very first thing what I'll do, I'll inform the stakeholder, see, this is getting delayed. Now if we have to finish on this on a particular date, I need to add more resource. Because we need to add more resource, the cost will be there. So I need your approval. So first thing I will inform the stakeholder with your analysis, and then you go for add the resource.
There is no option for analysis, conveying the analysis.
So what we should do, we first add more resources and try to finish on time.
Yeah, see, there is no option in either A, B or C or D which is suggesting that inform the stakeholders about your analysis or present your analysis to stakeholders, as was in the question which was we did yesterday or day or before. That was you are conveying you are telling the analysis and then asking for the support. Here you are informing that the project, either A says ask for more time, say my project is getting delayed, please give me more time. So this is opposite to C, and then asking then this B you are telling that your project will be delayed. So what the stakeholder will think? He will give you more resources? No, he will say okay, delayed, let me see what can I do. I agree with you that you have to inform the stakeholders before this, but before that you have to do analysis, let the stakeholders know, and then take action. But first two points are missing in this, so I can do only third point. If I have to tell people that I have two options, either I tell my customer that the project will be delayed, and second option I have to add resources. What will I do first?
Okay.
Add more resources.
Add more resources. There are two options available. Yes. I will take the add more resources option. The options you are talking about is not there.
No, actually in ideal, okay, practically we have to analyze the thing, say basically inform the vendor and tell him like this is getting delayed and the solution is to add more resources and get the concurrence for adding. This is the actual, practically in my view,
you have understood absolutely right. You have understood absolutely correctly, but the thing is that that part is not there in the option. Options I presented to me are either I have to convey to my customer that it is delayed, or I have another option to add resources. Which one I should choose? I have to choose within the given options. I cannot go out of options, right? I have to choose best out of the available options.
Okay.
That's the trick here. The trick here is that the things which you are seeing, that first analyze. So first has to be analyzed before you inform the stakeholders. That option is not there. Next is present your analysis to the stakeholder. That is also not there. Third is add resources. If that is not working out, tell your customer that it will be delayed. Or ask for more time. Make sense?
Okay.
Okay, from the perspective, okay, for that depends upon the perspective how we want to take, because okay, adding more resources is, if you see from the perspective of resolving the issues, okay, this is the action which has to be done. But looking at the practical scenario, I don't know, miss, because in practical life always the cost is a very sensitive issue where we have to we cannot take any action on. So practically speaking, this may not be the feasible solution to add without taking off or putting the resources without taking anybody concurrence.
I agree with you, but that's why
I don't know, maybe from the theoretical point of view this may be the solution.
No, it's not practical or practical. It is not about theoretical or practical. It is about choosing the best option in the available things. Choosing the best out of available options. Even in the life, even in the real life, you can choose only from the available options. If you think this might have happened, but that is not happening.
No. So in real life also, cost is a very influential factor where I cannot take decision of my own. Say if I am managing a project, I cannot of my own put extra resources without taking the due approval or this thing.
Amitabh,
it's not in my hand.
Amitabh, you are considering facts which are not presented anywhere. I am saying
exactly
those facts are not there anywhere, which you are assuming. You are assuming going out of the
No. Okay. I got your point. What I am trying to say is, still looking at the option, I will see informing stakeholder is better option than adding more resources of my own.
Yeah, see, the thing is that it is what I am saying. First of all, let's think from the question point of view. We are constrained with the available information. First thing. So in the question, whatever information is given there, I cannot assume anything more than that. Second thing, I have to choose best out of the 4 options given. This is from the question side. So that way, A, B, C is better than B and A. Make sense? Now come to the practical ground. Practical ground also is a...
That I am agreeing. That I am agreeing. Okay.
Yeah. In the practical ground also, the whatever you can do is whatever options available to you, you can choose best out of that. If the option, you might have think of a better option, but if that option is not available, you cannot do that, right? We face every day in our life. We thought that, oh, this would have happened, but that has not happened. Even in the life also, we can choose only, see, you have been given a bad thing and the worst thing. So what you will take? You will say, let's take worst one. It is not absolutely bad as such. It is a little better than the worst condition. That's what I'm saying. So it is not about the practical or theoretical. It is about that a situation is presented to us. We have to choose best out of the available options. Either it is either you on the ground or in the exam. It is the same thing applies. We move to the next option. Next question number 3. Let's go to question number 3. Whatever. Very good. Okay. Question number 3 is all C. What about question number 4? Let's go for question number 5. What about question number 5? A. The key input to activity definition, D and A. Key input to the activity definition is R. See, look at this. Activity definition means something should have not happened till that time. So if you look at this, network diagram is basically, unless you have identified activity definition, you cannot have a network diagram. And if you look at A, B and C, network diagram is present. Only D is there where the network diagram is not present. What about question number 6? B, A. Question number 6. I think one more response I'm expecting. Rajesh, it is A or B or something else? About question number 6. Okay, you said B. Okay. So B, A, B. Sorry, I just scroll up. A team member comes to the project manager and explains that he is not sure of what work he needs to do on work package assigned to him. Which of the following document is missing? He is talking about work package first of all, and he's saying what he's supposed to do. Therefore, what is supposed to be done is written in the WBS dictionary with respect to work package. Now, this is actually basically a scope question which is put into time management questions. So therefore, it create a confusion that is the WBS dictionary which is not there in time management, should we put it or not? Is that like that?
No, like I was thinking like he is aware of the work package, but he is not aware of all the activity list what is given. So activity list is not provided to him.
Okay, maybe this thinking is also, right as such. But what is saying it is not sure.
This is basically okay.
Needs to do, yes.
This is basically the work package. Basically, activity list define how the work has to be done. So activities is not clear about. That's what the thinking is.
Yeah, this thinking also fitting
start,
into a
how to
scenario as
start
such. So there is nothing wrong with that. But the purpose actually when we put this question was that where what has need to be done in the work package is written. So that is written actually in WBS dictionary.
know what to do, how to do, and where to do. This all is there in WBS dictionary. But activities, what are the actual activities that has to come from activity list?
Yeah.
That is not there. That's the reason he is not aware what are the activities he is to do.
Yeah.
Your thinking is also right actually, because say what work need to be done that can be defined with the number of the activities under it. That way it will lead to activity list. So I say yes. This could be little ambiguous, but the purpose was as to the option A. The purpose was where, because work WS dictionary keeps it what is to be done on the work package. But that thinking is also right that you say activity list says that what work is to be done, which is also right. So I will check this out. I think we need to make some modification to make it more unambiguous. Okay, anyway, the question number 7. Okay, question number 8. Great, that's good. So question number 9.
A little confusion on 8.
You have confusion on 8?
I had, yes. Although I have answered, yeah, can you just scroll up to 8?
Yeah,
I have answered C, but I was also, yeah, I have answered C, but I was a bit confused about D also, because D sounds the same as C.
The time and activity can start before finish of predecessor, but there is no such thing as such.
No?
You are talking about a lead.
It's
It's a lead. You're talking about a lead, right? This is not lead.
Okay,
This is
okay,
lead.
okay. Oh, yeah. Sorry. Yes.
Waiting time to start next activity.
Okay. Fine.
The definition itself.
Yeah.
9th is B. Okay, very good. Okay. E.
The meaning should say D.
You mean to say D. Okay. Then ka D.
Yeah, that is activity E.
Why not D?
Just wanted to discuss this.
Why not B? B and E in the same sequence, right?
Yeah.
On the
So
same path.
Actually, no, D and E.
no B. No, I wrote actually B only, but I just want to discuss this. How exactly this will go? So start. So first A will start on 0 on 3 days.
Then start is first is A, second is B,
B,
3 and 5, and then C is on A and B,
okay,
which is 4. Then D depends upon C, which is 3. Then E depend upon B.
and
Right, and 6 is This is 8, right? Correct. Now, which is the critical path? This is the critical path.
Yeah.
This is the critical path, right?
Correct.
Why not this? Why not B? Why E?
Yeah.
So when we crash,
Simply because it is having more duration.
B, if you do B,
How
it will
about
impact the path also.
No, the thinking is basically because it is having more duration, so putting more resources and crashing it is actually more the duration, it is simpler to do the crashing.
no, it's not
That's
simpler.
a preference taken to
More time you can get if the activity is bigger, but you need only
Yeah.
1 day.
Yeah, but okay, if the bigger the activity, it is easy to crash it, correct? So preference I will always do is where there is large number of time available, I'll try to crash that first.
Okay, let me tell you some principles of crashing. First of all, it should be on critical path. First preference. Okay, on critical path activity, crashing has no meaning. Second, earliest the better.
O, then B.
Why earliest the better? Because whatever repercussion of that is, we still have time to manage it. So earliest is better. Third is largest. Why largest? Only when you need more time. Here we need 1 day. That can be achieved on this as well as on this. If you need 3 days, then it would be difficult here. We may make this be as infeasible if we try to get the work done in 2 days instead of 5 days. While here, getting 3 days will be much easier. So in that case, I will prefer E. Then the fourth is any other factor, that is the cost factor. If cost is in,
And which is the less,
so
which is the less dependency?
I will say they are not in sequence as such, but they need to be considered. So if third is not required, we need to consider only the second one. If fourth is not the consideration, we have to look only on the second one. So
Okay.
1 day is required, that is achievable on this as well as on this. So I will apply the principle earliest the better. If I can get 1 day in 3 activities, I will choose the earliest one.
So best answer should be B.
The best answer should be B because it is earlier.
Okay.
If it is 3 days you need, then if D is the right answer. Last option is the right answer in that case. If cost is the factor, then we have to consider cost, where the minimum cost going, right? So it is B. Let's go for 11. D. Why D?
Because that is giving the more suitable 33 days. So 30 plus minus 3.
This is 30 plus minus 3, right?
Yeah.
The question is least risky. This is 26
We have
plus
taken
minus 4. So here the deviation available is 4. Here deviation available is 3. Here deviation available is 5. Which is the
5.
least risky?
5 1. First A.
A. If we say which is more accurate, I will say this.
Okay.
Because we are giving more precise figure there and with less deviation. But giving 30 days with plus minus 5 days, we are giving it quite a bandwidth. If somebody accepted, it will be less risky, least risky.
Correct. But is it correct to go with the optimistic, means the accurate number? So when we are giving the option A, so that's true, it's a least risky, but we are giving a lot of time on this.
Yeah, that is why it becomes, the deviation is high deviation we are giving, high like fluid is there. So 25 to 35 it can be completed. So the 10 days available, definitely it will be least risky, but it is not highly accurate. It is less accurate, least accurate in the as such. The highest accuracy is there in the D. If you say which estimate are more accurate, I will say D.
So answer should be A.
Answer should be A, right.
Okay. Especially in this context.
How do you take this mean of 28 days C push?
Mean of, I don't understand actually. That option is is nothing, communicating nothing actually has to.
That's communicating nothing, no?
Yeah. What about question 12? DC, okay. You are working with your team to estimate your new project. Your team is mainly facing challenges in estimating the project, as project has several new kinds of activity. Analogous is out of question.
Okay.
You decided to derive parametric, your per hour resource cost from earlier projects. Analogous out of question. Parametrics. And use this rate to estimate. Rate is a formula to new projects, estimate the new project. Is that clear now?
Yes.
Yeah. Parametric.
Parametric.
Parametric, yes.
What about 13? B? Okay. What about 14?
I want to describe this also.
Okay. See, if you look at the critical path, you will find B and A on critical path, right?
Correct.
Yes.
Both can be crashed. If I crash A by 2 days, my cost is 400. If I crash B by 1 day, which is possible, and crash A by 1 day, my cost will be 300. I have to crash only by 2 days. So instead of crashing A by 2 days, I will crash B by 1 day and crash A by 1 day. That will reduce my cost. Because the question here is optimum cost, not any other thing.
So 2 plus 1, so 300.
Right?
Okay.
Okay, so let's go for next chapter, which is cost management. Cost management is all about managing the project within budget. So first, estimating the cost. Second, defining the budget of the project, and then controlling the cost to complete the project within defined budget. So estimating, budgeting, and controlling the cost to complete the project within approved budget. Four processes. First is preparing a cost management plan. Second is estimating the cost. Third is determining the budget, and fourth is controlling the cost. Three are part of planning, one is part of controlling. What is cost management plan? Cost management plan is all about setting up a cost management system in place. That will be cost management plan. What cost management plan normally contains? Cost management plan contains what kind of accuracy you expect in the cost calculations. What is the unit of measure? Probably in the cost it is dollars, rupees, or any other currency. Setting up some control accounts, figuring out which control accounts on which we are going to work. So your control accounts, water control accounts, is very much similar to your cost center in your project, in your company. So establishing those cost center in the work breakdown structure is also the part of establishing the cost management system. And the fourth is control threshold. How much variance is acceptable, on how much variance we will take some measures. Like here, you have defined some upper and lower limit. Right? And many other things similar to this. You can define the performance criteria. You can define, as I said, control points. Control point means setting up control accounts at different places in the work breakdown structure. We will look into this, how we can set up these cost centers there. Employing the earned value, seeing that which kind of technique we were going to use for cost management. Here we will talk about earned value management. Earned value management which will be used for cost controlling. What kind of reporting format or reporting information as well as the format to be defined. So all these things we have put up in the cost management system, cost management plan, which will guide us to estimate the cost, budgeting it, and then controlling the cost. We can define that what kind of estimation technique we are going to use in the for cost estimation in the cost management plan. The first part is estimating the cost. You might have seen that most of these things we have already covered in schedule duration estimate. Now here the reserve analysis is little different than schedule difference. In the schedule we used, two things are normally used. One is contingency reserve and second is management reserve. What is contingency reserve? Contingency reserve for risks we have identified, right? The risk we have identified for the mitigation plan, or after, if the mitigation plan doesn't work or our response plan doesn't work, then we have to compensate the loss by the risk. That is our contingency reserve. Management reserves are either the risk that are bigger and beyond the project can handle, like your disaster recovery kind of thing. This can apply to multiple projects, not only this project, or the risk which you fail to identify. Those things are handled by management reserve. Additional estimation technique you coming into here is the vendor bid analysis. Vendor bid analysis is a very simple thing. Many times you don't have any idea, especially many times happen in government. You don't have any idea how this project will happen. How will you calculate the cost of such a project? So you invite proposal from the various vendors. You look at their approach and the quote and their quote, and then compare various bids together to understand how this project will happen and what should be its price. So that is called vendor bid analysis. If more than one people are available or you doing this work, which is normally the case, then effective decision making techniques are important. What you do actually, using any of these estimate, you come out with the cost estimate of each activity. As such, you know that for each activity what kind of resources and how many quantity are required. That helps you a lot in understanding that what should be the cost of the project, cost of the activity, plus plus adding some more things, whatever it could be. So normally if we do so, that on each activity what kind of resources required and how many quantity, and we club them together and go up in the WBS, that will call bottom up estimates. First at activity level, then at WBS level, then at higher WBS level, then at higher level, and then up to the project cost. So total project estimation can be worked out in this manner. Understand some few more terms which are important before we move to.
Excuse me.
Yes.
This vendor bid analysis is a simple analysis of the vendor cost, or I didn't get it fully.
See, you don't know how a project will be done. So you floated a tender, ask people to bid for it with the approach. So they give a quote with their approach. You compare, you get 10 such quotes. So you compare all 10 bids with respect to their approach and with respect to their cost. Now you can assess that what should be the approach and what should be the cost of the project. That is called vendor bid analysis.
Okay.
Learn from vendor how
Basically, based on
learn from vendors how what should be the right cost for this project.
like many times we do the small work at home, so we collect the estimate from the different vendor.
Yes.
And based on that, their criteria and all, what are the quality things are providing, we'll take the decision.
Right. Or you go to several malls, look at the same product, how much cost it is coming, and then going online and buying one.
It's true.
Right? That is also a kind of vendor bid analysis. Okay.
So that's the other way around. So I'm going different places, and vendor bid other way. We are collecting the estimate from different vendor and taking a decision.
Yeah.
But concept is same.
Concept is same.
Correct.
What is the direct cost?
It's directly impacting the project.
Yeah, like directly means suppose there is a training to be done.
So the trainer
Training
cost,
is a direct cost or indirect cost?
the trainer cost, equipment cost, and the facility what you're taking, that kind of cost is a direct cost.
Facility is a direct cost?
Yeah.
Okay. Suppose you have done a training. It's a direct cost, indirect cost.
I have done it training. Direct cost.
Okay. It depends. If it is this training is a specific requirement of your project. Suppose your project is having a new technology involved in your project and people do not know. You ask for a training for the resources. This training is done, it's a direct cost, directly we bill to your project. There is a interpersonal training. There is a to develop the interpersonal skills of the employees of your company. It is done for not only for your project, for all other projects.
So that will come indirect cost.
In that case, a factor of that training will come to your project. That will be an indirect cost. Now look at the facility. If the facility has been established especially for this project, then this facility's cost is direct cost to your project. But if you are using a shared facility like infrastructure in your company, electricity, the space available to you in the company is all come as an overhead, which is an indirect cost. Your bench cost is also an indirect cost because a factor of that is come into your project. You may not be knowing, but they are come as an loaded cost on each resource working on your project.
Yeah, but if the resource is going for any specific training from outside the premise, so this or if you are especially something arranging where the facilities has to be arranged, in that case, isn't facilities and all this will also part of the cost of the same
Look
project?
at the intent. If it is done especially for your project and it will not be used for any other purpose, it's a direct cost. If it is a general facility made available to you for this work also, it is an indirect cost. You will not have to pay a complete cost, but you have to pay a factor of that cost. Got it?
Yeah.
What is variable and fixed cost? Variable is a cost which comes from your operational expenses. Fixed costs normally come from capital expenses or capital account, and this is for operational account. The fixed cost is a cost which is once incurred cannot be changed, and it is done in specific things like you have developed an infrastructure. If it is developed the infrastructure, you have spent the cost. Your project doesn't completely use the infrastructure, not able to complete, but this cost is already done. It is come as a fixed cost. Your resource cost. Such costs are not manageable over the period of time. Look at the resource cost. If you reduce the resources, the cost will reduce. If you increase the number of resources, the cost will increase. Therefore, it is called variable cost. So over a period of time, so suppose you buy an equipment. It's a fixed cost.
Yeah,
it's a capital expenditure, fixed cost. But if you hire equipment, that is a variable cost. As soon as you remove this equipment from your project, the cost is gone.
But when you buy any equipment, suppose for any specific project, I bought a server,
yes,
and you're working on
yes,
it. But once the project is over and the purpose is solved,
yes,
even the equipment is with the organization.
yes.
So the cost which we have billed to the customer, we cannot bill the complete fixed that cost to the client, because that is with the organization and you're using for other purpose as well. So in this case, is this equipment cost will be a fixed cost counted to this?
I don't know, if you have charged your customer to the equipment, then keeping with you is not a good idea. It is not a fair game. You must give this server once the project is complete back to your customer, because he has a spend on it, not you.
Okay. So release that to them. Or
Well, practically also.
That case, in
it's unethical, integrity issue, right? Isn't it?
Otherwise, the hire will be the right in such situation.
Or you can tell customer, that this server we have used for the project, we want to keep it. And work out a revenue sharing model where you say, okay, I will give you this much money,
correct,
and I will keep this server with
correct,
me, which is fair,
yeah,
fair thing.
correct. Yeah, the skipping is not fair. Always inform, and then you can have the share of that.
In that case, it is a capital expenditure. It will be a fixed cost.
Correct.
If you have bought it, it is a capital expenditure. It is a fixed cost. If you have hired equipment, it is a variable cost.
So travel and all that will be not a fixed cost, because due to that particular project, the resource has traveled.
Travel is a variable cost.
Okay.
Only capital expenditure are fixed cost.
Okay.
CapEx and OpEx. OpEx is variable cost. CapEx is fixed cost. Okay, so various tools and techniques.
That's the reason always have challenge to maintain the OpEx.
Right, because you have to continuously manage it.
Correct.
You can optimize it actually. And the whole efforts of optimizing cost is all about optimizing variable cost primarily.
Yes. Fix has to go. Fix we cannot control on this. Yeah, that is
the control is less. You can only say you can find out some other options of, instead of buying it, you can say okay, I can take on hire, or let's share with some people. That is possible. So optimization is possible in the capital expenditure also, but normally when we talk about optimize the cost, is normally we are talking about variable cost. Okay, so using these techniques, you work out estimates of each activity, which gives you the cost of each activity, and the basis of estimation means whatever the assumption or constraint or whatever the basic data you have collected on which you have estimated the cost should also be part of there as a supporting document. Now once you have cost of the project, you have estimated the cost of the project. The next thing is determining the budget. What is the budget?
The total amount I can spend on the project.
Is that the budget?
No, total amount that has been allocated for the project.
That is allocation.
Total estimation. Total estimation is there for aggregate of all different head. That's the cost.
Again, that is the total cost of the project. It's not a budget.
Planning, budgeting is planning for doing the expenses. That is your budget.
Exactly. Planning to spend the estimated cost. That is budget. So whenever the budget, you think budget without plan of expenses is an allocation. Okay, so it is something like you have this thing, 1 WBS, okay. $10, $20, $25, okay. This is $55. Done. This is an allocation or estimated cost. Now you say this is A, this is B, and this is C. Now you say first we do A, before we start, then we start B, and here we start C. So how the project look like? It will look like this. Right? This is 10, 10 plus this is, okay, this, and then it will go like this. So this may be, this may be 30, this may be something more, maybe 40, then it goes like that. If I create a curve out of this, a cumulative curve, this is weekly or monthly expenses. Something like that. If I do an cumulative cost, it comes like this. So month on month, this is how I am going to spend. So by end of third month, I will spend this much. By end of fifth month, I will spend this much. This is called budgeting. So once I freeze that month on month how I'm going to spend the money, I freeze this spending of the money. This is I call budget. So time phased spending of the money is called budget. Time phase cost is budget. Right? This plus this is this plus this plus this is this plus this is this, then cumulative, it is cumulative, right? You got it, right? This normally come as an S curve. We call it S curve. And this S curve, freezing of this S curve is actually your cost baseline. And this is what your budget is. So at any point of time, month 2, you can see that you are supposed to spend this much, you spend this much or this much. Hello, are you getting me now?
Yeah, it's here back.
Okay, so time phased cost is budget. So this curve, S curve which comes out is basically your budget. Without expense plan, the either you have an estimated cost or you can call it as allocation. That way, like this. So you have, first thing is cost aggregation. So first you have to come out with the complete total required for the project. So you sum up the costing of each activity. Then you come on the work package side and you have established some control accounts. What is control account? Is equivalent to your cost center. You have this WBS, then activities, you have another WBS here, right? These are activities, these are activities, these are activities. Now I say here I have put up a cost account, control account, sorry, control account, say 2205, and here I establish the control account. You can see cost center 5520. Okay.
It's not visible actually. Your screen is not visible.
Are writing
I don't know why
something?
it is not visible.
Yeah.
Got it? Okay. So
Yeah.
this is one segment of the WBS. This is other segment of the WBS. I have put a control account against this 2205. Here it is control account 5520. Now total budget of $50. I have given $30 here and $20 here. This is how it is budgeted, right? So all the expenses here will be measured against this $20, against this cost account, control account, and this expenses will be reconciled against $30. That will be the cost control account of 2205. So in a multidisciplinary project, you can say if there couple of functions are working together, you can give that the function X, say R&D team, the allocation, the budget for R&D team is this much. For production team, the work is this much. The cost allocation or budget is this much. So you distribute the total budget in that sense, that how they're going to spend. And those are called control accounts. Your accounts actually measure or track the cost through the control accounts. We normally call it cost centers.
But before determining the budget, we need to work on the cost management plan and estimate cost.
Yeah, so first you estimate the cost, then you come out as a project estimate, put a contingency reserve on it, whatever is come out to be a cost baseline. So cost baseline contains project estimate as well as contingency reserve. Then there is a factor of management reserve, which is a total project budget. But this is not the project manager supposed to track. What project manager is supposed to track is this much.
Cost baseline, and cost baseline we will get from?
Cost baseline will come by distributing your work, distributing your like estimated cost on the activities, and the activities will happen this way, right? Your resource on or staffing level will come like this. Correct? So this is here, this plus this is here, this plus is here, this plus is here, and then here, and then here. So this is a cumulative graph, and this we freeze this. This is called project budget. Got it? Is that clear?
This includes contingency reserves?
This include contingency reserve, yes. It depends upon you. You distribute the contingency reserve at different stage, or you keep it separately.
So while doing the estimate cost,
if you keep it separately, it will come at the end. It will include in the end. If you distribute it, it will get distributed here in the expenses.
so budget at completion, that is your baseline.
Budget at completion is the total money you need to spend on project. This line is baseline. What this line present? This line present that by the end of first month, you will be spending this much. By the end of second month, you will be spending this much. By the end of third month, you will be spending this much. By the end of fourth month, you will be spending this much. Fifth month, this much. This month, this much. Sixth month, this much. So you can, at any point of time, you can check how much you have spent. So if you have spent less than or more than that, it will show that deviation from the what you have already worked out, what you have baseline. Make sense?
Yeah.
Based on this, you also forecast your funding requirements. This is for the projects which requires to purchase raw material and equipments, etc. For software projects, normally it is not required. But for the other construction and manufacturing projects, there are a lot of procurement is required. So those procurements are done based on your fund, that is there in your cost baseline. Based on that, you forecast your funding requirement, and your accounts provide the money based on your funding forecast. Last one is the control cost, but the thing is that, see you next week.
Okay, thank you.
Thank you very much. So for bearing me and all the time you are here and listening me. See you next week on Saturday, 7 a.m. India time.
Thank you.
Okay, bye-bye.